Hello students, today we will study the next questions, that is of exercise 6.2. So this is the topic of standard 9, chapter number 6, lines and angles. So what is the question? Question number 5 is, here we have given one of the diagram in which line AB is parallel to CD that we have given, and angle APQ that we have given is 50 degree. Angle PRD we have given is 127 degree. We have to find the x and y. Here we have to find out the value of x and y. So see, first of all understand the diagram. These two lines AB and CD are parallel that we have given. There is a triangle in between the two parallel lines. The triangle is PQR. Right? Okay. One of the angle, this APQ, we have given that is 50 degree. One another angle that is PRD, that is 127 degree. Here is the angle Y, that is QPR, that is angle Y. And here is the angle X, that is PQR. That we have to find out both the values X and Y. So see how we can find out these values. Okay, here we can notice that we have given that AB is parallel to CD. Now we can consider PQ as one of the transversal. Okay, so when we consider PQ as a transversal, AB is parallel to CD and PQ is a transversal. So we can see that here angle APQ will become equal to angle PQR. Why? Because of alternate interior angle. These two angles are what? Alternate interior angles. Right? Because the Z is formed here. See. Right? So this angle and this x both are equal. So APQ is what? 50. And PQR is what? X. And therefore this is the value of x. We get the value of x, that is equals to 50. Now think about this y. How can we get the y? See how we can. There is two methods. First method is we can consider AB and CD line as a parallel. We can now take PR as a transversal. When we consider PR as a transversal, this angle APR and PRD will be equal. This angle APR is made by the two angles 50 and y. So we can write down 50 plus y is equals to 127. In this way, first way we can find out the value of y. Second method is what? Here the two angles QRP and PRD both are on the same straight line. So both the addition, this angle and this angle, total will be 180 degree. Okay. From that we can find out this value of this angle QRP. Now according to the angle sum property of the triangle, this value x we already have. We have find out this value. Now we can find out the value of y. So these are the two different methods, right? Okay, we will use this method. Here we can write down that line AB is parallel to CD and PR is a transversal, right? So now we can write down angle APR will be equal to angle PRD. Why? Because of alternate interior angles. Right? Now angle APR is what? See, angle APR is the addition of the two adjacent angles. First is APQ, and APQ is what? 50. Plus second angle is APQ plus QPR, and QPR is what? Y. And this PRD is 127. Now when we take this 50 to the right hand side, we get the y is equals to 127 minus 50, and therefore we get the value of y is equals to 77. Now this is the value of x, that is 50, and this is the value of y, that is 77 degree. Okay, so here you can also use the second method that I have already said. Okay, so this is how we can solve the question number 5. Now let us study the question number 6. The question number 6 is, here also we have given one of the figure. PQ and RS are the two mirrors placed parallel to each other. See, we have given that PQ and PRS are the two mirrors, but they are parallel to each other. An incident ray AB strikes the mirror PQ at B. One of the ray AB strikes this mirror PQ at a point B. From here this ray reflects. See, the reflected ray AB strikes to mirror PQ at a B. The reflected ray moves along the path BC and strike the mirror RS at a C. This ray AB reflected from this mirror PQ moving towards the path BC, again it is incident at a point C, that is of the point mirror RS. Again reflects back along CD. Again this ray reflected back as a path CD. Okay, prove that AB is parallel to CD. Here we have to prove that this AB ray and CD both are parallel to each other. That we have to prove. So see, simple, there is a two mirrors which are parallel to each other. One of the ray AB incident at a point B, then reflects, again it is incident at a point C, again it reflects. So its path is A to B, B to C and C to D. And we have to prove that AB and CD are parallel to each other. So here one thing we have to construct, that is we have to draw, here we have to draw a perpendicular, let us say the BM. We have to draw a perpendicular BM which is perpendicular to PQ. So PQ, okay, here we can take the BM. BM is perpendicular to PQ. Let us draw BM that is perpendicular to PQ. In the same way, here we have to draw a perpendicular that is of RS. So next construction we have to do is CN that is perpendicular to R. Now, why we draw these two perpendiculars? Because in science, in chapter of the light, you have studied or you will study about that the angle of the incident and the angle of the reflection. Both are equal. Now, which angle is called the angle of incidence? This is the surface, PQ is the surface. The ray is reflecting here, right? Incident here. So the angle which the ray makes with this perpendicular of the surface, that means this much of the angle. This much of the angle is called the angle of reflection, incident. And when this ray reflects from the here, then again it will make one of the angle with this perpendicular, and this angle is called the angle of reflection. Angle of incidence, angle of reflection. Both are equal. So let us give it the angle number 1. This is angle number 2. Here also same thing will happen. This BC is incident at this point C. So angle of the incidence here is this much with this perpendicular, right? This is, let's suppose 3, and this angle which again reflects, that is suppose 4, right? So here that is why we draw these two perpendiculars. Now, right now we can write down that angle of incident is equals to angle of reflection, right? So here we can write down that angle 1 is equals to angle 2, right? Give it the equation number 1. This is what at point B on mirror PQ. In the same way, we can also write down that angle 3 is equals to angle 4. Give it equation number 2. This is where at point C on the mirror RS. See, now we have here the two equations in which angle 1 is equals to 2 and 3 is equals to 4. Now, as we know that this both PQ and RS are parallel to each other. PQ and RS are parallel to each other. BM is perpendicular to PQ and CN is perpendicular to RS. So, therefore, we can write down that BM and CN are also parallel to each other. Right? BM and CN are parallel to each other. Now, here we can write down that BM and CN are parallel to each other, and we can now consider BC as a transversal. BC is a transversal. Right? What will happen? These two BM and CN are parallel to each other. BC is the transversal. So this angle 2 and 3 are making a pair of alternate interior angles. So that we can write down that angle 2 is equals to angle 3. Why? Because of alternate interior angle. Right? Understand it carefully. See, this is the BM, this is the CN. Two lines are parallel, and one of the transversal BC is that. So this 2 and 3. See, Z is formed here. So this 2 and 3, both angles have the same value according to the alternate interior angles. Now, give it the equation number 3. Now see, from equation number 1, 2 and 3, what we can write down? Angle 1 is equals to angle 2, angle 2 is equals to angle 3, and angle 3 is equals to angle 4. That means all the four angles are equal to each other. So, from 1, 2 and 3, we can write down that angle 1 is equals to angle 2 is equals to angle 3 is equals to angle 4. Now here we have to take only the two angles, that is angle 1 and 2, 3 and 4 are equal. So here also we can write down that angle 1 plus angle 2 is equals to angle 3 plus angle 4. Now when we add these two angles 1 and 2, what we get? Angle ABC. Angle ABC. So here we can write down angle ABC. In the same way, when we add 3 and 4, we get the angle BCD. Angle BCD. Now see, the two angles ABC and BCD are what? Equal. If we consider AB and CD as the two lines, one of the transversal is BC, and these angles are making a pair of alternate interior angles. So according to the theorem 6.3, if the two alternate interior angles are equal, then the two lines are parallel to each other. Right? So here we can write down that if we consider the AB and CD are two lines, and BC is the transversal. BC is the transversal. BC is the transversal, and these two angles are equal. So here give it the equation number 4. So here we can write down from equation number 4 and from theorem 6.3, we can write down that AB is parallel to CD. AB is parallel to CD. Now what is the statement in the 6.3 is whenever two lines, that means AB and CD, are there, one of the transversal BC intersect the two lines, and if the alternate interior angles will become equal, then the two lines are parallel to each other. So in this way we can here prove that the AB and CD are parallel to each other. Okay, so in this way we can solve this type of problems. Okay, so this is all about this lecture. Thank you.